Okay, welcome back to the second video. We're going to continue going on through IGCSE Unit 9, periodic table, and now we're going to be working on the second video. So if you haven't watched the first one yet, these videos are created in series, so you'll have to kind of watch one before the other to fully keep up. So what we covered in the past, in the last video, if you're not binge watching these videos, is group 1. Remember, group 1 has one valence electron. Group 2 has two valence electrons. Remember, group 3 has three valence electrons. We call vertical columns, so vertical columns in the periodic table, we call them groups, and horizontal column or horizontal rows we call periods. So vertical columns are groups, and horizontal rows are called periods. And what we said is that groups, so elements of the same group, have similar, so it's not identical, similar chemical reactivity. And remember, we went over the reactivity of group 1, the trend in reactivity of group 1, and the trend in reactivity of group 7. So the trend in reactivity for group 1, right? It gets more reactive down the group, and group 7, it's less reactive down the group. And remember, we related that to how they like to give away electrons. If they've got more layers, they don't mind losing that outer electron very, very easily. So that's group 1. But the thing is that as you work down the group, right, group 7 likes electrons. So if an electron, flies in here, the further it is from the nucleus, the less it likes the electron, the less it cares if it has electron. So with group 7, the smaller, basically, the less layers there are in the element, the more it can attract electrons. So it increases its reactivity if it can attract electrons more. Okay, so what we're going to do right now is we're just going to cover two more trends. So two trends, and this is going to be metallic versus non-metallic character across periods. And we're going to cover melting point and boiling point across period 1 or period 2 and period 3. So okay, let's talk about metallic versus non-metallic character. This is one that you don't really need to memorize as much. Let's just look at the periodic table, right? If we look at the periodic table, we see metals, semi-metals and metalloids, and non-metals. So what we can say is that metallic character, so how much something acts like a metal. So metallic character, I'll change the color for this one. Metallic character decreases across the period from left to right. So as we move from left to right across the period, we started, alkali metals. So, if you remember our unit that we did on naming the different areas of the periodic table, alkali metals, alkali earth metals, and we had some of our metalloids. We had our non-metals, our halogens, and our noble gases. So that's one important one to know, is just that metallic character decreases across the period. And the second one, melting point and boiling point across a period 2 and 3. So let's look at periods 2 and 3 right now, right? So we're looking at this period, and we're looking at this period. So let's see, we've got metals we've got, right, carbon here. We've got a metalloid right here. Carbon, we've got a non-metal. And then we've got our ones that are typically gases, right? Oops. Got our ones that are typically gases. And remember though, we studied the structure of diamond. So this is going to be, a little bit of a game, right? We've got metals, something that's kind of like a metal, but kind of like a non-metal. This is going to be a non-metal, but carbon, right, forms a macromolecular structure. And remember, the properties of macromolecular structures is that they had very large melting points and very large boiling points. So what we can say is that, lithium and beryllium has more metallic bonding than lithium. We don't necessarily need to know that. You'll learn that in IB next year. But beryllium has more metallic bonding than lithium. But then we get the borons. We're getting away from metals. So we can't really talk about metallic bonding anymore. Then we get to giant molecular structures. And we get to simple molecular structures. So what we do is we work from metals, which we know have a high melting point and boiling point. Then we got to macromolecular structures, which we know was carbon and silicone, both formed macromolecular structures. And we have simple molecular structures. So this will be like our halogens and gases. So we've got, if we were to draw, a graph of this, what we'd see is that, let's look at the periodic table. Lithium, beryllium, boron, and carbon. What we see is lithium is here, beryllium, boron, carbon, and then finally nitrogen, oxygen, fluorine, and neon, and small e, and E. So if we were to look at the boiling points, they go up, 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 and then they crash. Do. So the trend that I want you guys to see here in the periodic table is we go from metallic. So remember, we only need to know period 2 and 3. Metallic to giant molecular to simple molecular. So what happens is that the boiling point and melting point increases from group 1 to group 4, and then decreases from group 4 to group 8. So it's kind of, you just need to imagine a period, or a pyramid. Not in the period, I'm just stuck in this chemistry mindset. But imagine a pyramid, and you've got the same thing, right? The boiling point increases, and then it decreases. But it doesn't increase, not just like a pyramid, because it goes up, and then it sharply goes down. So we see this giant drop right here. So that's one of the trends that you need to know, is that metallic character to macromolecular bonding to simple molecular bonding. So metallic bonding to macromolecular structures to simple molecular structures. Simple molecular structures. So those will be the next 2 trends that we need to know. So we need to know the trend of reactivity down group 1 becomes more reactive, down group 7 less reactive. Metallic character decreases across the period. So from left to right, metallic character decreases. And we have to also have melting point and boiling points for period 2 and 3 increase, and then sharply decrease. So we need to know, if we had a type of graph like this given to us, You can say, oh, that looks like the trend in melting point and boiling points across a period 2 or 3. Okay, I will see you in the next video.